Okay, so let's think about waiting line. Suppose there's a line in a grocery store that has about 10 people show up per hour, standard deviation of 1, and the checker can process 12 people per hour, standard deviation of 1.5. So on average, the checker is going to be able to handle the input, but they will get behind some of the time. And so we've got two random processes, how many people show up and how many people get processed. So this is 10, 1, 12, 1.5. We want to know after an 8-hour shift, what is the average number of people waiting in line? So for that, we're going to hop on over to Excel here. And so we need to make a column for waiting, or let's see, we need show up, total processed. So we've got 10 on average that show up and 12 on average that are processed. And we want to know what happens after an 8-hour shift. So show up is equal to norm inverse rand 10 1, and then processed is norm inverse rand 12 1.5. So there's our show up on our process. So now, unless we need some times here. So we'll have our period 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 periods. So let's think about how long the line is. So in the first period, the line is show up minus processed. That's pretty straightforward. In period 2, though, we have show up and we have processed. Oh, I made a mistake here. So this needs to be a max of this and 0. Right? If we're going to get through them all, we just have 0. If we're not, then we have however many are left over. So in this case, we didn't quite make it. Now notice that we're talking about 0.375 people, so these are fractional people. If we wanted to, we could scrub that out, but that's not usually worth worrying about. So I think in your problems, you'll just happily just do decimals of everything, and that's fine. So I've got people showing up, people leaving. So let's think about this line now. So again, we're going to do a max with 0. But now, because we've got people left over, we've got 0.375 people from the previous period, we're going to take the leftovers from before, add it to the people that show up, and subtract off the total that were processed during the time period. So old line plus new additions minus process. So there's our, let's see, so now let's find one. Okay, so look, so we had 1.6 people, but we processed 3 extra, so we're back to 0 here. So now in this case, right, we were short by 0.8, 0.9, or 0.8 or 0.7, but it's actually 1.3 because of the 0.5 from the previous period. Okay. The way I've got it set up, we're doing this plus this minus this, right? This plus this minus this. That's a spatial relationship. We can fill it down. So I'm just going to highlight these, click and drag, and get my 8. Okay, and then I can say, all right, here we go. Here's this. And so now I've got my things here, and I can fill down, although we have to be careful. Notice that my time periods are moving strangely, so you have to be really careful with that. It's an easy way to make a mistake. So we need to type another one. And to get these pasted again. And these pasted. I'm going to move these down a little bit. Okay, and now hopefully it will not count up. What is it doing? Nope, that's no good. Do these as text, I think, does it? There, now it should. Let's see. Send and copy. Paste. Okay, so now we're just repeating over and over again. So I'm going to go to 2000, delete the extra. Okay, so now what I've got is notice I've got a list of lots of different simulated days, and at the end here is the number of people waiting in line at the end of the day. And I've put it over on the side because now I can take all of H, and we're going to do an average. I'm going to do an average of these. It says H38 to H2100. We get an average number of people waiting in line that bounces around quite a bit, but you get an estimate. So if we did a million rows or 100,000 rows instead of just 2,000 rows, we'd have a lot more simulated days, and our average would be more stable. So part of the reason this is moving around so much is that it's a whole bunch of zeros, and then randomly it'll be a big day. So there's actually quite a bit of random variation in what the line is at the end. So keys to doing this correctly are we've got our two simulated inputs, and then we're carefully putting it in output. So there's logic here that's really important to waiting lines, in that you are adding the Q to the old line and subtracting off the process from the combination of the old line and the new additions, making sure that it doesn't go negative. You need a max in there. So there's actually quite a bit of important logic in this cell with respect to waiting lines. So that was a line example. So when we come back, we'll take a look at a stock market example.